Let's talk about nitrogen for a second. So nitrogen is an interesting element. We already talked about that. It's a plant nutrient, so it's required by plants to grow. And in many natural environments, it's a limiting nutrient, so we have to add additional nitrogen to our agricultural crops to make it grow. Otherwise, it wouldn't work. Where do we get all this nitrogen from? From the atmosphere. And the atmosphere is a major reservoir of nitrogen. Yeah, 78% of the atmosphere is made of N2 gas. But for a long time, it was not usable for us until these two guys, here, Haber and Bosch, they invented the method called after them, yeah, named after them, Haber-Bosch procedure, and they found out how to extract atmospheric nitrogen and produce nitrogen fertilizer for agricultural use from it. Okay, this happened well early in the 20th century. Before that, the world population, we got it here, world population, was about 1.617 billion people, and it would have developed if there would have been no nitrogen fertilizer from Haber-Bosch procedure. It would have developed like that probably. So this is the forecast, because there wouldn't have been enough food to feed much more people, because the agricultural harvest wouldn't be so good. But since we had this procedure and since we were able to use atmospheric nitrogen for agricultural fertilizer, the world was able to sustain many more people, yeah. And this curve is expressing the actual development of population on a global scale. But this also shows you that about half of the population on this planet is fed by Haber-Bosch nitrogen. Wouldn't be able to sustain on this planet without the Haber-Bosch nitrogen from the atmosphere. That's amazing, isn't it? I always find this very amazing, this connection. Fact is also that now more nitrogen is fixed synthetically from the atmosphere for fertilizer production than is fixed naturally in all terrestrial ecosystems. Yeah? Nitrogen is taken up by terrestrial ecosystems, part of it, yeah? But we human beings are taking up more than all the natural environmental systems, ecosystems on this planet, at least terrestrial ones. That's amazing. We were talking about the carbon cycle a lot, only shortly. In a nutshell, we have the problem of fossil fuel burning. So we have an input into the atmosphere from fossil fuel burning and cement production. We do have important CO2 sinks like the vegetation, yeah, vegetation which conducts photosynthesis. They take up CO2, but also the oceans take up a lot of CO2. We were talking about that, right? Okay, but these things are in sum not sufficient to make up for the increase here from fossil fuel burning. So we got a net atmospheric growth of 4.3 gigatons of carbon per year in the atmosphere, and this leads to massively increased CO2 concentrations in the atmosphere. Nearly half of the emitted CO2 is actually not sequestered, so fixed again, in natural terrestrial marine ecosystem accumulates in the atmosphere. And this leads to what we call the greenhouse effect, responsible for climate change. As we already said, it's good that we do have some greenhouse effect. There is also a natural greenhouse effect, which is driven by, for example, volcanic emissions of CO2 or natural emissions of methane. Yeah, and we have these greenhouse gases naturally around our planet. Otherwise, if we wouldn't have that, the temperature on this Earth would be minus 18 degrees Celsius all over the world. So we wouldn't be able to live here. Now it is plus 14 degrees Celsius, and getting warmer. Okay. The atmosphere, this is in a nutshell how it works, yeah, also a repetition for what we said earlier. The atmosphere is basically transparent for the shortwave solar radiation, ultraviolet radiation, but it's not transparent for the re-emitted long wave infrared radiation. So this will result in a warming, and this will result in glacier melt, sea level rise, and maybe a possible runaway greenhouse if we do have self-strengthening circles, as they are sometimes called. So maybe if the glaciers melt, there will be a decrease in albedo, so the reflectability of the Earth's surface, and this will then lead to increased absorption of heat on the surface, which will in turn accelerate the glacier melting, and so on. So a vicious circle leading to a so-called runaway greenhouse, which we saw in the history of this planet already, yeah, but which we should by all means avoid to meet again in our human history.